Okay, so this is a recording for do's and don'ts for the statistics part of your AS exams. We'll go through some of the things you should definitely look to do and some of the things you should definitely look to not do. All right, we'll start with measures of location and dispersion. So here we're talking about the mean, the median and quartiles. Those are measures of location. And we're talking about standard deviation, interquartile range. Those are measures of dispersion. Okay. Said it many times, the very first thing you need to look out for in any time that you see a grouped frequency table is to close the gaps in the data. So you can see right here, so you can see that the original data over here went from 0 to 9, 10 to 19, 20 to 29, and immediately I needed to close those gaps to make sure that any follow-on calculations were correct, particularly when it comes to working with interpolation, also when it comes to calculating class widths. If we were then going to go on and work with a histogram, always make sure that you close those gaps in grouped data. Okay, next, I want you to make sure that you calculate the cumulative frequency. So we're talking about these values here. The cumulative frequency just needs to be calculated all of the time if you're going to work with interpolation. Something to also look out for is that this last value matches the value that you were given in the question. So that will be a rough sense check that you have got your cumulative frequency correct. Always use a diagram for interpolation. It's often too easy for you to make a mistake by not having the diagram and thinking I can just do this straight away in my head. It takes 10 seconds for you to produce this diagram. Just be patient with yourself, do the diagram, be sure that you're going to get the marks that you deserve. With that said, obviously to locate our values, we're going to use our usual n+1 over 2 for the median, over 4 for the lower quartile, etc. So use those. Then going down the cumulative frequency column, we're looking for the first value that goes beyond whatever position you found. For me, or for this question, we found that it needs to be in this interval. 72 was the first number that went past. We looked at those, and these are the two values to use. 29 and 72 for the position, 19.5 and 29.5 for the actual values for the distance. All right, be careful not to switch these around. I've seen a few times where people have put the 60.5 in the middle of the 19.5 and the 29.5, which is why I've even color coded it just to make it really clear exactly where each of the values should be going. Even it should just make sense to you. 60.5 is a particular position. 29 and 72, they were also positions. So they should all occupy the same row. Okay, setting up the diagram usually leads to correct answers. So if you get the diagram correct, we should be happy to get the rest of the marks there as well. Okay, something else that I want to point out is do not round too early. Just in general, good rule of thumb is 4 decimal places. All right, give your answers to 4 decimal places. This may be used later on in a calculation, and usually 4 decimal places will maintain your accuracy even though you have rounded. So I'm going to insist that nobody rounds to 1 decimal place for any of their answers. We're not looking for that. We're looking for lots of accuracy. This is statistics. Okay, next, I just want you to be smart about when it's time to put data in order. In this question, we were asked to identify the upper quartile. The values as they are, these coteen levels, are not in order. So for you to try and find the position, etc., and locate the upper quartile or any of the quartiles would not lead to the correct answer. So don't just take for granted that the data will be in order. You check and order it for yourself if necessary, just like I did in the example. Okay, substitute straight into formulae. Often you will be given summary statistics, just like we have here. We've got the sum of fx and we've got the sum of fx squared. Don't try and calculate these things for yourself. I've seen people who will spend exam time, who will spend their time working these out for themselves. If you had a table, they would want to work it out from scratch. Just be smart and know that they can substitute straight into the formulae. As soon as you have a standard deviation question, I'm expecting to see these 3 things written out even before you've put any substitutions. What I've got in red, that should be written straight away, and then you're just substituting values into those formulas and then resubstituting your solution or resubstituting your result into the next formula and then resubstituting your result into the next formula. Okay, get it right, get the formula down, substitute and keep it moving. Okay, next let's think about our coding questions. I want you to rearrange your coded formula. As soon as you know that you're working with coding, at some point this formula is going to need to be rearranged. So here I've written it out, and you can see that I've got y bar equals x bar minus 755 all over 2.5. This is because both addition and subtraction are going to impact the mean. But straight after that, I've rearranged and I've made x bar the subject. As soon as I've had that, I then substituted the value that I had for y bar so I could find my final answer. Make sure that you've written the rearranged decoded form. Similarly, I wrote out the coding formula for the standard deviation, remembering that addition and subtraction have no impact on the standard deviation when it comes to coding. So from there, I rewrote the equation, and then once again, I substituted in to get to my final answer. With coded questions or coding questions, make sure that you rearrange the coded formula to make the original value the subject. Okay, so a couple of things to point out on this one. All right, be careful not to calculate any unnecessary values. Down here in the lower half, we were asked to show that there is only one outlier. Okay, a lot of people at this point were tempted to go back to the original data and recalculate the upper quartile and the lower quartile because that's your favorite way to identify outliers. But you don't have time for that in the exam. You have been asked to already calculate the mean, which you've gone ahead and done, and you've gone ahead and found the standard deviation. We should be using these values to identify our outlier. So using these values, we need to find the outlier by x bar plus or minus 2 sigma. That's the version that we're expected to use. Don't spend time calculating unnecessary values. You will get some credit for it, but you're penalizing yourself with the time that you have in the exam. In the exam hall, you're not just fighting to show that you know all of this mathematical content, that you're good problem solvers, that you know what you're doing on the questions. You're also fighting against time. You cannot sacrifice time. You just need to be efficient, super efficient in that exam hall. Okay, next, make sure that you show any comparisons that you've been asked for. So here, if we're trying to identify that something is an outlier, we've set the outlier boundary. Okay, show how your value, 38.1, show how it compares to the outlier boundary. Okay, so just saying it's an outlier, you may drop a mark for that. Make sure you just show that quick comparison. Okay, and the next thing to look for here is just the positive and your negative skew. Do not get them mixed up. So how do we identify positive skew? We're going to look at the diagram, okay? Whichever direction it's been stretched out in, that's what we call the skew. So this has been stretched out into the positive direction, that's the skew. That's always where the mean is going to be located. So this value right here, that would be the mean. This value here, that's the mean. So the direction the mean has been pulled in, that's going to let you know what type of skew you're looking at. So here we have positive skew. And what we're saying on this diagram, also, we should be able to identify the mode, the most popular part, the piece on the diagram that is the highest, that shows the highest frequency, where the peak of the diagram is. Any way you want to remember it, that's the mode. All right, if the value for the mode is smaller than the value for the median, or it's smaller than the value for the mean, then we're working with positive skew. Same the other way around. If the value for the mean is smaller than either the median or the mode, we're also identifying negative skew. Okay, so make sure that you've got the diagram sorted. You know which statistics are at which parts of the diagram. Okay, also from box plots, we should be able to do this in exactly the same way. So for a box plot, if the difference between the lower quartile and the median is smaller than the difference between the upper quartile and the median, that means that the same amount of items is packed into a tighter space. And if you imagine that crumpling up together, that is what gives us the peak that we have on the diagram above. So once again, this is positive skew, whereas if that was the larger of the two, then all of those values have a lot more space. That's the side that's been stretched out. That's the negative skew that we're looking at. Be extremely careful not to get your skew incorrect, and to make sure that you justify the skew that you have, okay? We're looking for one of these two. We're either looking for you to use part of this or part of this as your justification for the skew that you identify, okay? You only need to use two parts of this inequality,